Good morning, Year 12s. Today we're going to look at the Visitors of the Southwest booklet, so I'll ask you to get those out now. Yes, Oscar, we're going to require a pen for today's session. Okay, let's have a look here at this table. So we've got 1993 to 1996. We've got numbers of visitors in their thousands per month. So the first thing this worksheet asks us to do is to graph the data. So here's one I prepared earlier. And we've got these numbers in. So what I want to do to graph this is click A and B. They're the two things I'm graphing. I'll click graph up the top and I'll click scatter. Now you'll notice I've put my values from 1 through to 12 on there. That's so when I've got my x-axis here, my data is continuous over a period of time. Now at the moment those points are all over the shop. So what I'll do is click view and I will do some lines. Those lines now clearly identify the peaks and the troughs in my data. So in question 2, it says, is there any trend? Yes, we can see there's a long-term increasing trend. For question 3, what predictions can you make for the future? We would say that the visitors increase. We would suggest that they increase more prolifically in summer, and there's still troughs during the winter months. Where do the peaks occur? They occur in the first 4 months, as we can see each time on our graph here, here, and here. And then the troughs occur in the second set of 4 months. All right, so let's move on. If you turn the page here, it says graph the data is shown below. This one looks a little bit fatter than your one, and that's because their x-axis is more stretched out. Now we want to put a moving average on. If you've watched the Charlie Watson video, you'll be all over this and you'll know what to do. If not, let's have a look at how we can put our 3-point moving average into our ClassPad. So your first job is to set this graph at number 2. Click on that. And then you want to drag that all the way down to 11. The reason for this is because I will not be able to get data for a 3-point moving average for the first or last of the months. Once I've got this, I can go edit, copy, cut. No, don't want to do that. Cancel that. Edit. Let's paste that back. Let's try again. Edit, copy, edit, paste. Okay, so now we've got the months that we want the moving average for. We click on the box for D and we'll start up a little formula here for this. So we're going to go equals. Now Cooper would always remind me to put a bracket in first. I'll then collect B1 plus B2 plus B3, close the bracket, divide by 3, and we'll get 35, which is what we're after, as we can see on the graph. Now, again, to fill this, we're going to click on the corner of that box, like that. We're going to drag that down to 11. Then at the top, we're going to go edit, we're going to go fill, and we're going to go fill range. Check that your formula is correct, okay, and there it is. You can see our numbers are very slightly different to the ones on the table, and that's because ours have got further decimal place values. So now we've got that, we can move along on the sheet. And you can see they've drawn that smooth data. So again on the ClassPad we can do that by collecting these two pieces of information. We can go graph, and go scatter, and now you can see our dots are in a linear form. Now what we want to do is start making some predictions with this line. This smooth data line is great because it's a more accurate linear line. So to do that we're going to do what we would do in bivariate data, and we're going to go calc, regression, linear regression. As you can see now I've got A is 2.65 and B is 30.2. So our line will be slightly different to the one that they've got here. So let's write ours in. Ours would look like this. We've got M is equal to, we had 2.65 X plus 30.2. Okay, so what this means, we need to understand this line. This means that there will be 2.65 thousand more visitors as each month goes up. That's my gradient. And the 30.2 means that's the y-intercept. So when the time was 0, or at the start of 1993, they were anticipating on average 30,000 visitors per 4 months. Okay, if you wanted to now make a prediction, you could use this line. So let's say here that we wanted to find, they're saying the 11th month. So if we wanted to use the 11th month for ours, we could do this. Now I've got a little calculator here, I'll quickly type that in. We'd go 2.65 times by in brackets 11 plus 30.1. And then we'd get 59.25. So we'd go 2.65 brackets 11 So that means that there would be 59.25 thousand visitors in the 11th month of that time series. Okay. Is there a problem with that though? And the answer is yes. The problem is that is a smooth data point. So as you can see on the graph here, that is just this smooth data point. It wouldn't actually be reflective of that specific month in the data. So to be specific to that month, what we would require is a seasonal component. So that's what we're going to look at now. So the seasonal component is what this table looks like here. Now, this takes into account how many more visitors are visiting in that summer period in the first 4 months as opposed to winter and the third months, which is probably like the shoulder season. So to find this number, what we've done in each of these, as you can see on here, is these here are just the average number of visitors for that whole year. So you add up the 3 for the year, divide by 3, and you get that number. Now to find the percentage of the 4 monthly mean, all I'm doing here for the first one, for example, would be 45 divided by 35 times by 100. So you're finding that as a percentage. Obviously, if the visitors is higher than the yearly average, your percentage will be over 100%, which this one is. If, as you can see in the second one with 26,000 visitors, that's significantly lower. And as you can see as a result, when you do 26 divided by 35, you only get 74%. What we need to do is now go through this and do that for every single month. So I'm just going to do it for the summer months with some numbers that Mrs. Allen's prepared for me on these solutions, if I can find them. And we go, for example, this one here would be 64 divided by 52 times 100, and then you would get 123.1%. Do it the same process again for the 1996, and you'd end up with 118.6%. Now, if we go down to the table below, what this is doing is now accumulating all the percentages for those first month periods. So you can see this is for 1993, 94, for 95 we had 123.1, and for 96 we had 118.6. Now what I want to do is add those 4 up, these 4 here. I want to add them together. I want to divide it by 4 because there's 4 of them. And then that will come up with the figure of 122.1%. What that is my seasonal component, and that's really important. What that number does is it says that there's 22.1% more visitors than the yearly average for the summer periods for the data we have. So when it says what do these mean percentages add up to, I haven't actually done the third one, but what these 3 should add up to is 300%, obviously. So you can see this one is above and this one is below that 300%, showing the visitors above or below. So what we need to do now is we need to apply this to our data. So if we went back and we took this figure here, which was what we expected the number to be for period 11, we could then go and apply that to this period using our seasonal component. So if we took this seasonal component here, we work out which season it's in, and we apply that, we could then do 59.25, and we can times that by 0.8, and that will give me the 80% less. If I do that on my calculator, I can go 59 and that will give us 47.4. Now this number here means there'll be 47,400 visitors expected for that period, and that number there is far more accurate because that has taken into consideration the fact that there will only be 80% of the yearly average in that particular month down there, okay, which would be here. Alright, there is one other way we can do this, and that's through the residual method. So the residual method is a little bit more simple. It takes the same principle, but it uses the 3-point moving average. And with each 3-point moving average, it just compares the actual visitors that you can see here to the 3-point moving average at that period of time. And then it leaves it as a result. So for example, the first one's 9. If I did 34, take 37.3, I'd get minus 3.3, as you can see on the table below anyway. And then if I did it again, 52 take 41, I'd have a positive 11. So these numbers are showing how far above or below the 3-point moving average it is. What we could then do is exactly the same as back here, and we can collate the information for those 4 points. So for example, if we were doing the second months of the year, we would grab the second months, we'd grab this -9, or here, we'd grab the -6.7. We'd need to work out these two, which Mrs. Allen has kindly done for us somewhere. That's -10.7, and the last one, which is -10. So we'd add these two in, -10.7 and -10. And once we've done that, we'd divide by 4 and we'd come up with this. So this is the average residual for the second months of the year. Once we've got that number, we can then, as you can see, take it away to our prediction from our line of best fit that we made by Variant Data Star way back on our ClassPad in here, okay? All right, hopefully that's something for you to get on with. Once you've done this, get cracking with exercise 2C. Any questions, please email us or message us through WebEx. We'll be back with some more videos tomorrow. Bye.